So, hello everyone and welcome to Excited Nuclei channel. So, today we are going to do our last project, that is the matrix calculator app. And in this project, basically, we are going to do some interesting matrix operation. And before that, this is going to be your last beginner level project. So, let's start with the PPT part. So, this is going to be your project. And introduction, of course, this is going to perform some metric operation like addition, subtraction, multiplication, determinant calculation in the console. Objective basically input and display matrices, perform operations, calculate determinant, and handle errors. And also concept use is going to be 2D arrays, loops, function of different operation, conditional statement, input output handling. So basically, this is what this program is all about. Now, when talking about the next thing, and that is going to be just a second. Yeah, so the next thing is the demo part. So let's just start with the demo. As you can see, when I execute this app, it is showing us some options like add matrices, subtract, multiply, and determinant. So first of all, I am going to do something like adding matrices. Now it is asking for the number of rows in the matrix A. I say 2, and is also 2, basically the columns 2 by 2 matrix, and also by 2 by 2. So as you can see, now it start asking me the elements, and now for the 0 position, I am saying 2, sorry, 1, 2, 2, 3. Let's say this is going to be your matrix. Now it is asking us for the elements of matrix B. I'm going to just give the same to actually verify the output easily. So as you can see, after completing this addition operation, we get the real resultant matrix here. Now, in the similar way, we can do the other options too, operations too, like multiplication of matrices, and this can be done by simply, let's say, number of rows 2 and 2 and 2 and 4. Basically, 2 by 2 matrix is A matrix, and 2 by 4 matrix is going to be the size of matrix B. Now let's start with the elements of matrix A. Let's say 1, 2, 3, and 4. And for the matrix B, we are going to say like 1, 2, 3, 4, and again 1, 2, 3, 4. And as you can see, we get the resultant matrix of size 2 by 4. So basically, this is happening. Actually, we get the code really good. Now, in the similar way, we can also calculate the determinant of a matrix. Now, let's say I want to calculate the determinant this time, and going to ask for the elements in the 2 by 2 matrix. So, of course, I'm going to make it an identity matrix so that it is going to be clear to everyone. So as you can see, the determinant is 0 because every time the identity matrix determinant is always come out to be 0. Now if I try to run it again, but this time I am going to create a matrix in such a way like 0, 1, 0, 1. It's still 0. Of course, I know some of the people know that about the determinant. So basically, we are just going to calculate a 2 by 2 matrix determinant right now, because that is the end of my knowledge. Because when I see how to calculate for n by n matrix, it says recursion. So I don't want to deep dive into the complex parts in C++ right now. That's why I have only just hard coded a 2 by 2 matrix one. So if I say 1, 2, 3, and 4, it is just going to give us -2 determinant, and that is expected because it is going to be something like first 1, then here 2, then here 3, then here 4, and the determinant of 2 by 2 matrix can be simply calculated by 4 multiplied by 1 minus 2 multiplied by 3. So as you can see, it is giving us -2. So that's how this project is actually working. Now, when we're talking about the coding part, as you can see, we have set the max value to 10. Basically, this is the size of how much matrix can be bigger. So these are the functions that I have created, basically input matrix, display matrix, adding, subtraction, multiplication, determinant. Now, why not we start with determinant? As you can see, as I just already said you, that the determinant of 2 by 2 matrix can be calculated by multiplying its you can say diagonal element and subtracting it from the other elements multiplication, and that's how we are basically calculating the determinant. Now when we are talking about the input matrix, so that's how we are taking the input. We are just simply basically creating a function with some two parameters, basically four parameters, sorry, and the parameters are like an array. Basically, it is a 2D array of 10 by 10, 10 by 10 size. Now here we are also passing some argument like R and C and a correct and a name argument. So basically the name is going to be like matrix A and matrix B. And for the R and C, we have just seen that how it is going to be. It is basically the input of rows and columns, and then we using two nested loops. Basically, sorry, one nested no loop, and that is for loop. The first we are using for I is equal to 0. Basically, we are taking input for we are basically iterating through the rows, and while we are iterating through the rows, we are also taking the input for the columns, and that's how this function is actually working and creating our array. And after creating the input matrix, we are going to display the result matrix, and that can be simply done by taking these three argument array, rows, and columns, and then simply calling again the nested loop. But this time, rather than taking the inputs, we are just slicing the array one by one, and then putting a space there, and then after you can say after we complete a single row, we are just putting an handle there, basically to move to the next line for the next number of rows. Now we have actually taken the input, and also we have displayed the result matrix. Now it's time to see how these three functions are implemented: add, subtract, and multiply. So these are basically most simple functions that we have seen. Basically, here again we have two nested loops, and but this time we are just updating a C. That means the resultant matrix with the values of A plus B, and that's how we are creating this. You can say resultant matrix C. And similar way, we are basically subtracting A minus B, but things changes when we are talking about the multiplication of matrix, because there are many things that comes into play, such as the size of matrix should be like this. Basically, the size of matrix for the multiplication should be like aij, sorry, a of I1 j1. Basically, I1 and j1 are the matrix. Now if we want to multiply these two matrix b, or maybe yeah, b I2 j2. So as you can see, if you want to multiply A and B matrix with corresponding size I1 j1 and I2 j2, there needs to be a condition that needs to be satisfied, and that is j1 must always be equal to I2, and the resultant matrix R is going to be the size of I1 j2. Now that's how the matrix multiplication happens. Basically, we first take the row of first array and the column of the other array, and we multiply the element wise. Basically, we perform the element wise multiplication and then sum all the values, and we get the element of that particular position. So we use two loops as stated before, and then we basically initialize the first element, or you can say ith Cij element to 0, and then use a simple for loop where we initialize a k variable, and k is always going to be less than c1. And why? What is c1? C1 is basically the columns of first matrix. And then again, we what we are doing is we are just going to do that Cij is equal to Aik multiplied by Bkj. Basically the same things that we have written here is performing right now, and we are also adding everything after multiplying the elements. So that's how we are basically creating this matrix multiplication program. Now this is the program that we have actually created. So if so with that, I say we have actually completed our beginner level programs, and I just want to say that these programs, these projects actually can be made to the intermediate level too after implementing of some things like using the vector matrix, using the some F stream library to handle the files and everything. So maybe in the intermediate level, we can do one thing. We can just simply uh, improve these programs with the intermediate level skills. But right now, I think my proficiency only allows me to do these things at the current level. So that's all. And thank you for all watching this video. So let's meet in the next phase of our learning, that is intermediate level skills. And again, I will start sharing my progress with everyone. So thank you.